Hey everybody. All right, so we're jumping into the next chapter, unit, or whatever. This is all called hypothesis testing. So what we're going to do is you're going to get some data, and then you're going to be able to say, all right, I think the researcher was had enough evidence to prove that their hypothesis, their idea was right. Think um, the researcher did not have enough evidence. All right. So this part right now, I'm just going to explain the concepts so that once we start doing problems, you can understand them a little more. All right, so normally when you design an experiment, you choose a stance or an idea. So maybe I think that energy drinks increase blood pressure. I don't know. All right, and then I would design a study. Um, I would have maybe two groups. One group doesn't drink energy drinks and they take their blood pressure every day. One group drinks energy drinks one a day and they take their blood pressure every day. Then you decide the correct test, whether it's a t-test, a z-test, or a z-test for proportion. Then you decide your level of significance, like, do I want to be 90% correct with a 10% chance of being wrong? Do I want to be 95% correct with a 5% chance of being wrong? Then you formulate a plan. So you figure out like how I'm going to do this study. You do your study and then you figure out your conclusion. All right, so your statistical hypothesis is like your idea, your conjecture about the population parameter. So even though you're doing a study, you're going to infer that it would apply to the whole population. So I would infer, even though I'm studying, I don't know, 20 people total, 10 people who drinks energy drinks, and 10 people who don't drink it, and then 2 people who do drink energy drinks, and then I would take that information, I would infer it about everybody who ever drinks energy drinks. All right, so there's two kinds of hypotheses. Anyway, English. Sometimes not even English. Okay, so there's the null hypothesis, and there's the alternative. Okay, the alternative is also called the claim. It is what you're trying to prove. All right. If I'm trying to prove or claim, okay, that yes, there is an increase in blood pressure for people who drink energy drinks, that's what I'm trying to prove. And so my null would be the opposite of that. So I would say, okay, no, there's not. There's no difference. You cannot go into an experiment or a study or survey or whatever trying to prove that you're right. You try to disprove that you're wrong. So you're doing the opposite, and so it can get really confusing. And so there's three kinds. There's the two-tailed test. There's a one-tailed right-tailed and a one-tailed left-tailed test. All right, for a two-tailed test, notice, okay, what's similar about all these? This is the null, that HO, the HO, right here. Notice it's always the mean, right here, is equal to some value. Okay, so K is just some random number. It's the mean, but it's a like mean of the blood pressure or something. And then these things change. So on a two-tailed, you have not equal to. On a right-tailed, it's greater than. Notice on the right-tailed, that points to the right. On the left tail, it points to the left. Backwards. Okay. So all I want us to do is like practice what the null is and what the alternative is. That's all I'm going to do for a couple of problems. All right, so an engineer hypothesizes that the mean number of defects can be decreased in a manufacturing process, robots, humans. The mean number per 1,000 is 18. All right, so this is the null. And then the researcher hypothesizes that it's less than 18. All right, so this is the alternative. It's also called like the claim, like what the researcher is claiming. Okay, and that's all I want us to do right now is just practice. A couple things we know about this. It is points to the left, so it is one tail, and it is left-tailed. Right? Null is HO, Alternative, we're going to do H1. Sometimes it's called HA. All right, the researcher thinks that if expectant mothers use vitamin pills, the birth weight of babies will increase. The average birth of the population is 8.6. So they're claiming it's going to increase 8.6. All right, this guy is the null. This guy is the alternative. What you're trying to claim, I don't understand. Oh, sorry, I'm retarded, but there's another fly. So maybe I'm smelling sweet or something. I don't know. It looks like a mosquito or something. Sorry. Super fun time. All right. So this guy is like what the researcher claims. And so what you do is you try to prove or disprove the null. And then if you disprove the null, then you automatically are correct about your hypothesis. All right, a psychologist feels that playing soft music during a test will change the results of the test. The psychologist is not sure if it's going to be higher or lower. So we don't know. In the past, the mean was 73. So now we don't know what it's going to be. So that's the null, and that's the alternative. Oh. All right, this guy is one-tailed. And it points to the right. This guy is two-tailed. And remember, like two-tailed is like this, and so you've got stuff over here and stuff over here. One tail to the right. Tails over here. One tail to the left. Tails over here. And so like you're looking for information, like what I'm saying is you're looking for information in that area. You're looking for information in that area. You're looking for information here and or here. All right, so here's an example of a experiment. You can read it on here. I already gave an example. All right, so we have statistical test. The tests that we can use are the t-test, the z-test, z-test for proportion. And then with each of these, you can do the traditional way, or you could do what's called the p-value method. Right, and I'm going to show you all 6 ways, and then we're going to learn like what to do when. All right, the test value. So what we're going to do is we'll decide like if it's left-tailed, right-tailed, if it's two-tailed. And then we're going to calculate a test value from one of those guys. And what that test value is, it's a critical value. So the critical value is either positive or negative. And if it's right-tailed, then we would shade over here. If it was left-tailed, we'd shade over here. If it was two-tailed, we'd shade both. And then we're going to, so the critical value, and then we'll get a numerical value that's our test value, and we'll compare the test value to the critical value. So maybe it's right here, or maybe it's right here. And then the shading we reject. If it's in the not shade, we accept. There's some rules. All right, so you can get some errors. You can get a type 1 and type 2 error. I just really would rather you know that there's two errors. A type 1 error is when the null is true, okay, but you reject it. And then the type 2 error is when the alternative is true, but you go ahead and accept the null instead. Okay. So let me give you an example. This happens all the time because of racial profiling. So there's a guy getting on a plane, and they are not sure if he's armed or not. And so in order to ensure the safety of the passengers on the plane and in the airport, they're going to draw some conclusions. Maybe they saw like when he walked through like the metal detector, they saw like a little blip or something. And so there are some options that could occur, or there's some scenarios that could occur. All right, so he's really safe. Like the thing that they saw was he had a hip replacement or something because he was a vet. Okay, and so it was just metal in his hip. There was nothing else. And so he's actually safe. And so they go and do a like a pat down, and they realize, yep, there's nothing there. He has the documents for his hip replacement because he was shot in the hip. I don't know. And he gets on. So that's fabulous. The other is he's not. Like there's something, maybe he has like a, I don't know, a gun he manufactured out of plastic or something. I don't know. And so they go and pat it down and they find it and they say, you cannot get on the plane. This is not happening. So that's also a good conclusion. But here's where the problem lies. The problem lies in, and this happens a ton more than it should. So the passenger is safe. So he really, had the hip replacement. He has the papers, and they say, no, that's not enough. They say, okay, he's safe. And so he has some, I don't know, fake papers or something, and he's actually not. And so they allow him to get on the plane. Or they think he's not safe at all. They don't care that, he's got his documentation that, says all this stuff. And he is truly actually innocent. They don't let him board just because of their fears or racial profiling or whatever it is, cultural profiling, bias, all that kind of stuff, and they don't let him get on. And so those are like the two kinds of errors that could occur. Just like an example of each. All right, so you can do, there's level of significances. It's the exact same as it was before. 10 mean alpha is 0.10, means there's a 10% chance of rejecting the null. You can do alpha is 0.05. That means there's a 5% chance of rejecting the null. You can do alpha is 0.01, which means there's a 1% chance of rejecting the null. And so you'll always be given that. These relate to the 90%, 95%, 99%. And you'll be given that information. All right, I'm going to pause the video because this takes a little more time to explain, and I'll explain this in the next video.